I was walking through the ground floor and I saw this big booth. I'm looking, wow, CHC Nav. I know something about them.
Almost the biggest one here, no?
Yeah, welcome Andrei here. Tell us, what's your name, what's your position? How is it possible that it's your 15th, you said?
Yes.
15th INTERGEO. So tell us a little short story about you.
So first of all, thank you, colleagues, for invitation. Yeah, pleasure to be here. Yeah, my name is Andrei Gorb. I'm for CHC. I work for 8 years, last 8 years, and I'm a segment manager for mobile mapping division. Responsible from the beginning when no one know our LiDAR technology, when we integrate other products. Yeah, so from the scratch we develop mobile mapping global division in the market. Yeah, the previous experience I work for Leica Geosystem, 4 years in the company, in the Leica itself, 6 years with a partner. Yeah, so that's why just short CV descriptions I have generally.
So you must know everybody at INTERGEO, right?
Yes.
It's hard to navigate among people.
Yes. Yeah, so the Geo is always a good place because here everyone shows the latest technology. Here we get new idea, we share the new idea, see the people, see the friends. Yeah, it's definitely a good time.
So give us maybe a brief introduction through the portfolio you have. When I was checking the website, like you have very wide range of the products.
So historically, CHC came from the GNSS business because it was a big Trimble distributor in China. And then in 2003, the owner, George Zhao, he's here these days. He sees the big challenges between what people can buy in China. It was a poor time, so receivers cost from the famous brands cost quite a lot, 40,000 USD. And then with vision, like I will give oxygen of fire to the people. So he said, I will bring the GNSS product, GNSS location-based service to everyone. Yeah, and then we start the own brand. Those time collaborate with Trimble, make chipsets from Trimble, make some covers by CHC, make some software. That's how we start. So first 10 years, company spent just on their own GNSS receiver. And then we think about the solution business. So companies start to invest in different technology, machine control. We get it from the Nanjing. Mobile mapping in 2017, we acquired some company in the Wuhan, focused on the reality capture survey. So they did it by themselves, but we acquired them to start a big business. Then came marine division, this yellow boats, same drone we have on the air, same drone we have on the water acquisition. Then agriculture business came. So now we have totally 7 divisions in the company. Still the surveying, the GNSS, classical GNSS and total station are the main one. So we say we definitely the leader in the GNSS business. For us, if you will see the factory and you know the factory ability, 1 minute to produce one GNSS receiver by the robots. Yeah, from the raw materials, robot delivered to the factory and 1 minute for one receiver. Yeah. Mobile mapping became the second because we believe that industry will transform. So once everyone use the optical product, theodolites, total station, but once GNSS came, you need a 6 hours for survey, but then they say it was revolution, yeah. And no resections, nothing, yeah, just stay open sky. So now we see the same with reality capture technology. So we believe the GNSS market will be transformed to reality capture scanners, sensors, LiDARs, SLAM products. Yeah.
So you're basically now trying to push the side of the reality capture or the division of the reality capturing. So it's about SLAMs, it's about drones. What else do you count into this division?
Yes, so you see now we even provide our reality capture experience to the GNSS division because these days we release significant new product. We call it I-100, the GNSS, but with a SLAM inside. So when we released it 2 years ago with handheld SLAM RS10, we start to talk that we will bring the GNSS indoor. So without any GNSS signals, without any fixed solution, you can able to measure your XYZ coordinate indoor. RS10 was the first try. It's a great SLAM scanner, but it was not optimal on the weight on the pole, 1.9 kilogram. You need to keep energy management, 1 hour of survey, so GNSS should work longer. Yes. So now with this I-100, we bring the SLAM device inside, so the GNSS algorithm see when it not have a fixed solution, it will switch to the SLAM trajectory computation. So it's a first type certified device. So that's how we share technology between the reality capture sensors. So as I say, for example, if we speak last year, totally 250 RTK receivers was produced globally. Yeah, so that's why it's a huge industry. But we think that reality capture sensors will transfer this industry. Yeah, like historically, total station was a big amount of product. Yeah, when GNSS came, the product range became smaller, and now majority of surveyors use GNSS. So we want to do the same with reality capture sensors. So more and more surveyors will be involved in this kind of data acquisition.
But it's interesting what you're saying about the GNSS receiver, including the SLAM, because I saw the RS10 where it's actually SLAM attached with the GNSS
Antenna, yes.
in the hardware, like you
Yes.
cannot remove it. Okay, so
Yes.
it's the natural integration of the product. So when you're speaking about the GNSS that has SLAM, is it like a full feature SLAM or how good is it?
So the SLAM algorithm itself, we continuously improve because we have our, let's say, know-how and ecosystem. We teach our SLAM because company is global. We have 1,000 partners. So we collect the data where SLAM works in poor environment, in the tunnels and the open lands of India, for example. I was 2 weeks there. So we have the data, we educate our SLAM to be better and better in the hard environment. So that's why the new device we bring with version SLAM 2. So performance became better. And
Are you saying SWAM?
SLAM.
Oh, I'm sorry.
Yeah.
I got it.
So
I got lost. Sorry.
No problem. So the point is, first of all, the SLAM algorithm works much better. The second point, still it's a GNSS, so you do classical GNSS survey,
Yeah.
stakeout, survey, some cargo application, but you can do it indoors. So the point, still we specify SLAM scanner as a point cloud and the images, and this is a GNSS receiver. You can download, in case of I-100, you can download the point cloud, but it will be grid with 5 centimeters, so it's not too much details as a classical SLAM scanner can provide you, for some modeling, for other kind of beam application,
But you're speaking about the drones and the underwater drones or like
Yes.
water drones. Are you equipped? Do you have them equipped with like lidars or cameras, or what's the main focus
Yes.
there?
So expertise historically came from GNSS. That's why our, let's say, expertise on accuracy. Then we focused on the LiDAR. It was the first LiDAR which CHC developed by themselves, was released on INTERGEO 2022. It was a Alpha Unit 20. It's a classical mobile mapping sensor which we put on the vehicle. But here we provide the flexibility. We put it on any car, any kind of vehicle, drones, backpacks, helicopters, planes, any kind of setup. Now we have wide portfolio. We have a UAV LiDARs, we have a airborne LiDARs. And for sure from this year we focus a lot on the drones because we also think that industry will transform, more and more drones will be used. Even with our European regulation, US regulation, but still more drones will be allowed on the mapping project, on the surveillance project. So as the portfolio became bigger, back to Apache on the marine division, we also combine this kind of product with a SLAM device. We can put a RS10 on the top of our boat, or we can put a high-end scanner on the top. So I just have a presentation here on the main stage. I show the data combination. So we have a multi-beam mecha sounder below the boat, so point cloud below the water, and we combine with point cloud above the water. So river sides, lake sides, to have a complete data capture. And again, when we talk about Apache, we put the scanner on top. If we pass the bridges, we see the steel sections, concrete sections under the bridge.
But it's all connected via the GNSS coordinates, right?
Yes.
Okay.
GNSS and the SLAM. So we call it in the company as a hybrid positioning because previously it was a GNSS, then INS came, and now we have a SLAM, visual SLAM. So all of this combined for have more precise position in hard.
So maybe just to make it clear, because I misunderstood it before, and I think it might be confusing also for the viewers or listeners, or maybe not. But for myself, please just explain what the SWAM is actually.
SLAM, simultaneous location and mapping algorithm.
Okay, how does it work?
So this is a general algorithm. It's not a hardware. This algorithm needs some measuring sensor, so it could be visual like a camera, or could be a point cloud LiDAR technology. So it combines the data with a period of time. So it combines let's say simply, the algorithm will make a model, and combine same points of previous second with the next second, and make like a resection to understand, okay, I know this object last second, I see the same object this second, and then I know my position because LiDAR give you distance and angular measurement.
So it's something similar to this system in RTC360 from Leica in the TLS?
Yes.
Where it actually knows where it's moving within the
yes.
within the space. Okay.
Yes.
Thank you for clarifying
and
this.
that makes actually your boat drones or like water drones being precise then, right? Because it's also like constantly moving.
No, mainly the drones, if we talk about marine, because it's open lakes, yeah, it's not a closed water channel, so
Yeah.
they rely on the GNSS trajectory, INS trajectory. Same the UAV which find on the sky rely on the INS trajectory. But if we use a SLAM with a LiDAR, so we bring the drones, marine or UAV, whatever, we bring to the hard environment. So drones and more companies, you see, not just the CHC, you see can operate the drone in the mining industry, so in the tunnels, yeah, smaller drone or even bigger drone, yeah, like Matriz DJI. So we're doing the same. So SLAM extends operation of the UAVs and on the USVs also, yeah.
Can you tell us something about the X500 drone? I've seen some videos with testing, so I was amazed. Like, you went with it through rains, dust, extreme temperatures.
Yes.
So,
Yes.
Collisions.
what's
Yes.
that beast about?
So the point, yeah, we know there is a leader in the market, the leader in the industry, yes, and for sure we want to also have some market share because this market is booming, it's growing, yeah,
Yeah.
it's not decreasing. So CHC want to make the big grow in this industry, as we provide the LiDARs, yeah, so we also need a platform to carry them, also oblique sensor, different sensors. So X500 is our first but significant step in the UAV industry. I could tell you some insights. We invest on X500 more than we invest on each our LiDAR together. The investment is much bigger, yeah. So we make a new manufacturing line, we produce our own components, autopilot boards, everything, all the sensors made by us. So it was significant investment, yeah. So that's why, yes, we test in the different areas in very low temperature, in very hot climate seasons, like in India, in Saudi Arabia it was tested, yeah, or north of Canada, because we want to be sure it will work in all environments, yeah, because we know drones still have some limitations, yeah. Should be good weather condition, not so powerful wind, so we still want to extend this condition. And for sure, when we talk about LiDARs, majority of our partners, users, they still worry to put expensive sensor on the drone, because one day the drone can fall down due to some reason, yeah, even not human mistake, and you lose expensive payload. So we want to make a LiDAR, the drone robust enough, yeah, to land on the 3 props. So that's why we tested a lot. Yes, it could have a parachute, but also even the parachute sometimes not help. So the drone, this one, X500, can land on the 3 props. First of all, it's safety of the people. Second point, not to lose expensive payload itself. Yeah, so it can have more, all majority modern sensors, millimeter wave radar to detect all the collisions, cables, TV towers, whatever. Yeah, it's operate with high payloads because we not just CHC, many companies provide the different payloads. We talk about magnetometers, green LiDARs for the bathymetric survey. We talk about big oblique sensor with a high resolution. We talk about GPR on the. I'm from Ukraine, so this topic is very hot to find the unexploded mines. Yeah, so the drone can carry it because we can carry up to 5 kilo. We have very good endurance. We say with our LiDAR, with 1.5 kilo, it can fly 55 minutes. So we extend the operation time so to have a more efficient survey.
As we
Perfect.
are speaking also about like reality capturing processes, and the reality capturing is also often about visuals. How about the cameras which you have there? You mentioned oblique cameras. So is it something you have only on that particular drone, or is it something what can be also used on other drones?
Yes, so CHC, same as LiDAR technology or robotic platform USV and UAV, we also keep a camera technology. So first integration came in the GNSS. So all our GNSS equipment with at least 2 camera, one for photogrammetric task, one for the visual, we call it visual stakeout, to make for surveyors more easy understanding where to go. Same camera technology we bring to the RS10 device. So 3 camera, what we include, made by CHC. When we talk about UAV LiDARs, we equip our LiDARs with ortho and oblique sensors from the CHC. So it could be 45 megapixel, 61 megapixel, 130 megapixel oblique sensor. It belongs to CHC. Now it's a new stage. Again, on our booth, you can see we moved to the panoramic cameras for the vehicle-based data acquisition or for the background-based data acquisition. So now, these days, we released 48 megapixel camera from the CHC and 72 megapixel camera from CHC. It could be as addition to our LiDAR, to IU-20 system on our vehicle platform, or it could be totally standalone camera, because what we see, it's still huge demand of users, surveyors who need a camera on the solution. For the Google Street Map program, but also for many kind of applications.
So how many cameras are there on the how many sensors on the
for
set?
48 megapixel as a fisheye camera, we need 4 sensors to cover the panorama, 95% of the full sphere. If you talk about 72 megapixel camera, we have 6 sensors, 6 lenses.
How do you look at, as I touched the photogrammetry businesses, and we are asking this everyone today, how do you look at Gaussian splitting? And
Invest
position?
a lot. Invest a lot. Yeah, it's I couldn't say not modern technology. It's still growing technology. So more companies want to exploit functionality. So same as the CHC, we release this technology in our desktop software and our cloud software, and now it will come not just from our SLAM device, but also as we release this panoramic sensor, we will include this functionality. Yeah. And more functionality, not just visual tools, but measuring and the processing we will include in the future.
So can your clients already process Gaussian splits from
Yes,
your cameras
yes.
in your software?
Yes.
Great. So since you mentioned that you are growing every year, I expect you have already booked a bigger booth for the next year.
Next year will be very special. You know, it's the same time as Oktoberfest in Munich.
Okay.
So I could have recommendation to everyone to book a hotels in advance because price will be significantly high.
Oh,
Perfect,
Yeah.
perfect. So this podcast was done in a collaboration of our 3 days conference together with INTERGEO. So we are very happy that you were here, and
My pleasure.
hopefully see you next year at the INTERGEO and maybe also in Prague in 3 days.
Yes. Will be our pleasure.
Let's see.
Thank you
very
for
much.
invitation.
Okay, thank you.
Thank you
Bye.
very much.
Bye.
Bye-bye.